Hello, in this video we're looking at MEI FP2, the June 2010 paper question 1, which is on series polar coordinates and calculus. Read the question through first. We've got three distinct and unrelated parts here. They might just as well be three separate questions. Part A on series, Part B on polar coordinates, and Part C on integration. For Part A on series, we're given a function and asked to write down an expression for its derivative and to show that its second derivative is that expression given. We've then asked to show that the Maclaurin expansion of the function arcsine x plus a half begins as follows, and then to find the next term in x squared. Then for Part B on polar coordinates, we've got to sketch that curve, noting that A is positive and theta is between 0 and 2 pi. We've then got to find the area of the region in terms of A, noting that this time it's only 0 to pi, and the lines theta equals 0 and theta equals pi. And for the integral, note that we're asked to find an exact value. Okay, we've got f of t is arcsine of t. And therefore the derivative of that, copying from the formula book, is 1 over root 1 minus t squared. That's 1 minus t squared to the minus a half. And then using the chain rule to differentiate that again, I get minus a half 1 minus t squared to the minus 3 over 2 multiplied by minus 2t. The minuses cancel, as do the half and the 2, leaving us with t over 1 minus t squared to the 3 over 2. We then use that to find the Maclaurin expansion. So our function is arcsine of x plus a half. So f of 0 is arcsine a half. We know that sine of pi over 6 is a half, so arcsine of a half is pi over 6. If we then differentiate our function, that's the same as we got in Part A, where t equals a half. So that's 1 over root 1 minus a half squared, which is a quarter, 1 over root 3/4, which is root 4 or 2 over root 3. Second derivative, substituting in a half to our expression from the previous page, that's t, which is a half, over 1 minus t squared, which is a quarter, to the 3 over 2. That's a half multiplied by 3/4 to the minus 3 over 2 is the same as 4/3 to the 3 over 2. That's a half times 4 to the 3 over 2 is 8. 3 to the 3 over 2 is 3 root 3. So that's 4 over 3 root 3. And therefore the Maclaurin series f of x is approximately equal to f of 0 is pi over 6 plus f dashed of 0 times x, so that's 2 root 3x, which is what we had to start with. And then for the x squared term, I need to divide by 2 factorial, so that's going to be 2 over 3 root 3 x squared. Okay, polar coordinates. We're asked to sketch that curve for r equals pi a over pi plus theta. You can get an idea of what this looks like by choosing a value of a and using your graphical calculator, but we've got to do this in general terms, so it will be a good idea to write out a table to give us the points of intersection with the axes. So theta is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if theta is 0, I've got pi a over pi, which is a. If theta is pi over 2, that's pi a over 3 pi over 2, which is 2/3 a. If theta is pi, pi a over 2 pi, that's a over 2. Then theta is 3 pi over 2, gives me 2/5 a, and theta equals 2 pi 1/3 a. So marking the intersection points on my axes a over 3 and a, and then two-fifths a down here, a little bit further, a over 2, 2/3 a, and drawing in my spiral. The quality of your diagram will be mitigated by clear labelling. Of those intersection points. Okay, for the second part of this question, we're asked to find in terms of A the area bounded by the part of the curve for which theta is between 0 and pi, and the lines theta equals 0 and theta equals pi. So going back to our diagram, it's this bit here that we need to find. So the area is the integral from 0 to pi of a half r squared d theta. So we'll take the half out the front, and our expression was pi a, so pi squared a squared over pi plus theta squared. A is a constant, as of course is pi, so we can take those outside the integral as well. And we're just left with integral of 1 over pi plus theta all squared d theta. Okay, integrating that will give us pi plus theta to the -1, and I need a minus sign there. Check by differentiating that it does give us what we started with. And then substituting in the limits, if theta is pi, that's -1 over 2 pi. And if theta is 0, that's minus 1 over pi plus 0, 1 over pi. So pi squared a squared over 2 multiplied by 1 over 2 pi, which is pi squared a squared over 4 pi, or pi a squared over 4. Finally, part C, we're given this integral, and in the formula book we've got an expression for the integral of 1 over x squared plus a squared. So in order to be able to use that formula, I need to get rid of the 4. So I'm going to take a factor of 1/4 out the front, and then I've got 9 over 4 plus x squared. So a squared is 9 over 4, and therefore a is 3 over 2. Now I can simply use the formula from the formula book, which is 1 over a, so that's 2/3, arctan x over a, so 2x over 3, evaluated between 0 and 3 over 2. So that's 1/4 times 2/3, which is 1/6, arctan 2/3 of 3 over 2, which is 1, minus arctan of 0. Arctan of 1 is pi over 4, tan of pi over 4 is 1, arctan of 0 is 0, and we end up with pi over 24. Okay, let's have a look at the mark scheme for this question. So going back to part A, there's 1 mark for differentiating arcsine using the formula book at any form, as long as it's correct. There's a method mark for using the chain rule, and an accuracy mark for getting the correct answer, noting that the correct answer is given, so the working does need to be convincing. For part 2, there's a single mark for getting pi over 6. It does need to be clearly from f of a half. There needs to be a clear substitution there, otherwise you're not really showing that the first term there is pi over 6. Similarly for f dashed of 0, there's a method mark and an accuracy mark, but again there needs to be a clear substitution into your first derivative. For the next mark, you need to get 4 over 3 root 3, and you need to note that you've got to divide that by 2 for the Maclaurin series, and then an accuracy mark for getting the final series correct. For the polar coordinates question, there is 1 mark for a complete spiral, and that complete spiral does need to note that the value for 2 pi is bigger than the value for, the value for 2 pi is smaller than the value for 0. There's a second mark for getting these 2 points clearly labelled, or it being very clear from your diagram that we are decreasing as we go round. That second mark is dependent on the first mark being correct, and if your diagram is not fully correct, you score a maximum of 1 mark there. You don't need the shading to get the mark. That was just to help focus the second part of this question. Finding the area, there is a method mark for getting an integral in terms of r. There's an accuracy mark for doing that integral correctly and with the correct limits. There's a method mark for substituting those limits in, and an accuracy mark for getting the correct final answer. This method mark here, the expression you're substituting into does need to be of the correct form, even if it's not quite accurate. Finally, for part C, there is a method mark for noting that your integral is arctan of something. There are then accuracy marks for getting the a quarter and the 2/3 there, and the 2/3 x there. And then there's a method mark for substituting, which is dependent on the previous method mark, so you've got to be substituting in something to do with arctan, and an accuracy mark for evaluating that to get pi over 24 at the end. If you want to find videos of other questions on this unit or on other units, please visit the Further Mathematics Support Programme's website. Goodbye.